All right, I'm back again, and this is our last of the three types of transformations. This one's about reflections, and when we reflect a figure, every reflection has a line of reflection that you reflect over. So on these first reflections that we're going to do today, we're going to keep it simple. We're either going to be reflecting across the x-axis, like on this problem, which, by the way, this is problem 17 on your transformations worksheet. So again, you should have that downloaded by now and have a copy in hand so that you can follow along with me here. But on problem 17, we're reflecting across the x-axis, but there is also the possibility that we may have you reflect across the y-axis as well. So if we're reflecting across the x-axis, okay, then what I kind of like to do is to emphasize this. I like to take the x-axis itself and just kind of make a line across here, emphasizing that's the line I'm reflecting over. Okay, so all flips or reflections here are going to be done over that line. Okay, so it's as simple as this. Any points that are above that line after I flip them over that line will now be below. And any that were below, when I flip them over that line, are now going to be above. So if you just simply count how far away you are from your line, okay, like for example, this point M down here is 1, 2 units away from that line. So instead of being 2 units directly below, we're going to put it now 1, 2 units directly above. So there is my location of the point M prime. Okay, the T was also down below here. It was down 1, 2, 3, 4 units below. So I'm just going to count 1, 2, 3, 4 units above. Okay, and you keep it in line like this, you know, where it's still in line with this x coordinate of -5. So that's our new T prime. And then the N value was just simply 1 unit above the x-axis. So when we flip it over, it'll now be 1 unit below the x-axis. So there's my new N prime. Okay, and again, don't forget to join these at the end to make our new triangle. Okay, and you should find, if you did a good reflection, kind of a quick and easy way to check yourself is to make sure that the figure has symmetry around the line of reflection itself. So the x-axis, remember, was our line of reflection on this problem. So you'll notice that it looks the same above and below. Okay, the two triangles kind of look like they form a set of wings or something, like it almost looks like bat wings or something. Okay, but that's if you are reflecting across the x-axis. So that was problem 17. If we take a look at problem 18, okay, this time in the instructions they mention that instead of reflecting over the x-axis, we're going to be reflecting this one over the y-axis. So again, like I did on my last problem, one of the first things I like to do is emphasize that line that I'm reflecting over. So this time, instead of reflecting over the x, we're reflecting over this line, the y-axis. Okay, there's our y-axis. So instead of flipping up and down like we did on the last problem, this time we're going to be flipping from side to side since we're flipping over the y-axis. Okay, so it's other than that, it's the same concept. So we just have to figure out how far each point is away from our line of reflection. I, you can see here, is 1, 2, 3, 4, 5 units away. So I go 1, 2, 3, 4, 5 units on this side. So there's my new I prime. J is 1, 2 units away. So 1, 2 on this side would land him right there. And H has the unique property that it lies right on our line of reflection. So its distance from the line is 0. So that means that we have to maintain that distance. So we maintain a distance of 0 from the line, which means after flipping it over, it stays put. It's right there. It doesn't move anywhere. You know, it's kind of like this idea. If I put a point right here on my marker and then I turn this over 90 degrees, the point is still just on the back side of this marker here, but it's still on the marker, see? So same idea. If that point's there, you flip it over, it's going to stay there. Don't forget to reconnect these to make our shape again. So there's the resulting image, is our triangle H prime, J prime, I prime. And you can see it flipped over. Again, nice symmetry with respect to the line of reflection here in the middle. So again, it kind of looks like a pair of wings or I don't know, kind of like an anchor that's upside down from a boat. But regardless, very symmetric. So that's reflections. Again, all you got to do is watch out for what you're reflecting over. Make sure you understand if it's the y-axis, you're flipping side to side. But if it's the x-axis, you're flipping up and down. That's all there is to reflections, at least for now.